Good evening, children.
Good evening, ma'am.
Good evening, online children. Anirudh,
Good evening, ma'am.
Good evening. And Srijit. Good evening. I've shared my screen. Is it visible, online children?
Yes, ma'am.
Very good. All right. As you're aware that we have opened up 2 chapters, squares and square roots, as well as cubes and cube roots. Okay, so today we will just see some situations where the concept of squares and square roots can be applied in real life. All right. Look at this question. There are 11,236 chairs in an auditorium. All right. The chairs have to be arranged in rows and columns such that the number of rows is equal to the number of columns. Find the number of rows in which the chairs are arranged. So say you have 16 chairs and you want to arrange the chairs in such a way that the number of rows is equal to the number of columns. You have 16 chairs. You want to arrange these 16 chairs in such a way that the number of rows is equal to the number of columns, which means you want to make a square arrangement. You don't want to make a rectangular arrangement. If the number of rows and the number of columns should be the same, you want to, or you're looking for a square type of arrangement and not a rectangular arrangement. Okay, which means you will make 4 rows and 4 columns. You will make 4 rows and 4 columns like this. So you'll arrange the chairs like this. So this, in this arrangement, you can see 16 dots, so which represent 16 chairs, right? And see the number of rows: row 1, row 2, row 3, row 4. The horizontal ones are the rows: row 1, row 2, row 3, row 4. The horizontal ones are the rows. The vertical ones are the columns. Column 1, column 2, column 3, column 4. So now the answer is 4. You need to arrange the chairs. How many chairs do you have? 16 chairs. So now you want to make a square type of arrangement. So how many rows and columns should you have? 4. Now how will you connect 16, the number of chairs, and the answer 4? 16 chairs are what you have. And the answer to this situation, how many rows and columns should you have for this arrangement? The answer is 4. In the question, how many chairs are mentioned? 16 chairs. And there are some conditions in the questions, right? There are some conditions in the question, right? The number of rows must be equal to the number of columns. So what's the answer? 4. 4 is the answer. How do you connect 16 and 4? How are the numbers 16 and 4 related? 4 is the square root of 16. The answer 4 is the square root of 16. So the answer is the square root. For this question, the answer is the square root of 11,236. In our example question, 16 chairs. But in the question here, 11,236 chairs. What's the answer for our example question? 4 is the answer. What is the relation? How can you connect this number 16 and 4? 4 is the square root of 16. So what's the answer? The square root of the given number is the answer. So what's the given number in this question? 11,236. So the square root of 11,236 will give you the number of rows and the number of columns you should have for this arrangement to make a square arrangement. And you can find the square root using the long division method or the prime factorization method, but choose the long division method. See, if nothing is mentioned, always go for the long division method. Yeah, take down the question. Yeah, you can find the square root. Okay, you can do it in the main, meaning you can just start working, right? Yeah, maybe you can copy the question later. If you're curious to work the answer, just leave some 3-4 lines for the question and just start working the answer. Find the square root of the given number. No, the others can take the question. I'm just telling, he wants to work the answer. So write on the question. Yeah, okay, you can do that. But don't forget to copy the question later. Yeah, children, find the square root of 11. Please write on the question and find the square root of 11,236.
Ma'am, they didn't give the method, ma'am. Can we use like?
If nothing is mentioned, use a long division method.
Okay, ma'am.
Yeah. In word problems, the method will not be mentioned. So use a long division method. You can also use a prime factorization method, but choose a long division method. That's more convenient.
Okay.
Okay, I'm here to say that. Okay, he wants you to do it. Because if you say the digits, no, then they will just have to write it like that, the answer. Is your remainder 0? Very good. Very good. Sahasra and Srijit and Aniruddhan. Anirudh, right? Okay, sorry. Aniruddhan is that boy from Chennai. Yeah.
Yes,
Found the square root?
ma'am, 1 minute, ma'am.
Okay, okay.
I'm still doing, ma'am.
Okay. Last half an hour or I think 20 minutes should do. We'll see the answers to the assignment questions I shared last week on, I think, cubes and cube roots. Have you all completed? Srijit, Sahasra and Anirudh?
No, ma'am. No, ma'am. Ma'am, but we wrote the classwork, ma'am. I'm doing. Ma'am, I wrote the classwork, but I didn't do the
Homework? Homework. What about you? Mr. Danvin? No. Harini? Navneet? You finished all the sums? Oh, yeah. Okay. No, darling. Monday, Wednesday, 2 classes. So you have the Sunday in the middle, no? You have to, schedule. You will have to make a slot for the homework. No, that actually, children are not working sometimes, they're just selecting the answers. So randomly and I don't get to understand. You want that? Okay. I have to activate it again, actually. I have not, paid up. I just left it like that. So it's inactive at the moment. I can, activate it by paying up. So, okay, let me see.
Ma'am, the answer is 106, ma'am.
106. If you got that? Okay, 106. Let's see if Srijit and others are right. Perfect. 106. Very good.
Ma'am, yes, ma'am. I also got the same answer.
Very good. Very good. Yeah, please check the numbers at the different stages. Please check these numbers. Yeah. Oh, yeah. One more extra step. Yeah. You can do that. Yes. So I'll just explain this. Yeah. See here. One. All right. See here. So we group like this, 3, 6, 1, 2, 1 stands alone. 1 into 1, 1, 0 is the remainder. 1, 2 comes down, double the quotient. So it's 2 here. Okay, now you can also do like this. You can also do it like this. We have, that is, you don't see one step here, right? Here. I'll just tell you how to, like avoid that step. Okay, let me compare what we have learned and what is here. Okay, 1 second. So now what do we do here? We have to place a digit here and place the same digit here, right? So it is 0. 20 into 0, Avnish, is 0. And 12 is the remainder, right? And then the next pair, 3, 6 comes down, double the quotient, 20, whatever digit here, same digit here. So 6, 6, 206 into 6 is 1, 2, 3, 6, and the remainder is 0. But what you see here is, see here, this is what we have learned. This is also fine. I'll tell you about this. Now check your answer. If you worked it like this, check your answer. Yeah, it's fine. First one, second one, very good, yeah. So what you can also do is, see here. 1 into 1 is 1, 0. The next pair comes down. Listen to this. The next pair comes down. Double the quotient. Whatever digit here, same digit here. So 1 itself will become too much. 21 into 1 itself is more than 12. So it has to be 0, right? So what you can do is add a 0 here, 0 here, and bring the next pair down. Why? Because you know 12 only is going to be the remainder, right? 12 minus 0, 12 you're going to get again. So instead of doing that, add a 0 here, 0 here, and bring the next pair down. Otherwise, what you would normally do, 0, 0, and then you write, because 20 into 0 is 0, and then you 12 is the remainder. Anyways, it's the same thing, no? Then 3, 6 comes down. So you can avoid writing the 0 here and showing 12 as the remainder. Again, so I said 1 into 1, 1, 0, 12 comes down, 2, 0, 0. You don't have to place 0 here and then show 12 as the remainder. Write a 0 here, and then bring the next pair down. Now, 6, 6, 206 into 6 is 1, 2, 3, 6, and the remainder is 0. See, if you feel, no, I learned the earlier one first, so I'm comfortable with that, please proceed with that. Nothing wrong. Okay, so the chairs have to be arranged in 106 rows and 106 columns. Now, we need to understand another phrase for number of columns. How can you also call number of columns? What is the other way of, saying number of columns? So see here. This is not a square arrangement. It's a rectangular arrangement. You can see 1, 2, 3 rows and 1, 2, 3, 4, 5 columns. You can see 3 rows and 5 columns. So it's not a square arrangement. Okay, I'm not talking about this answer. We are done with the first one. I'm just trying to explain how you can also say number of columns. All right. So how many columns are here? 1, 2, 3, 4, 5. You can also, say columns as number of chairs or whatever object. Okay, so I'll just say chairs. Number of chairs in each row. How many chairs are there in each row? Each row, how many chairs? 1, 2, 3, 4, 5 chairs in each row. How many rows? 3 rows. How many chairs in each row? 5 chairs. So that is the number of columns. So you can also say, instead of using the word columns, you can say number of rows, number of chairs in each row. So number of rows is number of rows. Number of chairs in each row represents the number of columns. See here. So see here. How many rows? 1, 2, 3 rows. The horizontal ones, 3 rows. Okay. Now, how many columns? 5 columns. How can you also put it as, so count the number of chairs in each row? 1, 2, 3, 4, 5. How many chairs in each row? 5 chairs. But 5 is the number of columns. That's the other way of saying columns. That's the other way of saying columns. 5 is the number of columns, right? But what's the answer to this question? How many chairs in each row? What's the answer? 5. How many columns? 5. Oh, same answer to both. How many columns? How many columns? 5. How many chairs in each row? 5. That means what? If you're saying the same answer for both, number of chairs in each row and number of columns mean the same. Okay, remember that. Number of rows is different. Number of objects in each row is the number of columns. Once more, I'll say number of rows is number of rows. Number of objects in each row represents the number of columns. Yeah, finish it. Finish this one quickly.
Done, ma'am.
Very good. Yeah, time up. Yeah. Before I do this one, 1 second. No, 1 second. Yeah, yeah. 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 You don't have to worry about the question number. You take this question number 2. See this question. What is the least number to be added to 15,130 to make it a perfect square? Question number 2. Yeah. Oh no, just take it away now. Yeah. Okay, so what is the least number to be added to 15,130 to make it a perfect square? Now listen to this example. Please listen to me. Now we have this number, say 31. Is 31 a perfect square? No, 31 is not a perfect square. Now tell me the least number that is to be added to 31 so that the resulting number is a perfect square. 5. Because 31 plus 5 is 36 and 36 is a perfect square. See, the question is, you can add many numbers to 31 and make it a perfect square. See, if you want to make it 49, then you should add 18. You can add many numbers to 31 so that the resulting number is a perfect square. Yeah, the question is, what's the least number? What's the least number? So only one answer. Otherwise, you can add so many different numbers to 31 and make it different perfect square numbers. Smallest. Positive. Smallest positive number mostly. Least meaning smallest positive number. Okay, so 31. All right. So 31, the immediate perfect square is 36. So 5 should be added to 31 so that the resulting number 36 is a perfect square. So the answer is 5. All right. Now, listen carefully. 31. Now, to find the least number to be added or subtracted, you need to use the long division method. To find the least number by which it should be multiplied or divided, you should use the prime factorization method. See, you will get 4 types of questions. You may be asked to find the least number. You'll be given a number which is not a perfect square. You'll be given a number which is not a perfect square. And questions can be like this. What is the least number to be added to that number so that the resulting number is a perfect square? What number should be subtracted from it so that the resulting number is a perfect square? By what it should be all least, everywhere least. Not what is the least number by which it should be multiplied. So that the product, the resulting number is called the product, right? When you multiply something to a given number, the resulting number, the answer is called the product. So what is the least number by which it should be multiplied? The given number. The given number is an imperfect square. The given number is an imperfect square. So the question can be, what is the least number by which that given number, the imperfect square, should be multiplied so that the product is a perfect square? Similarly, the given number is an imperfect square. By what it should be divided so that the quotient, because when you divide two numbers, the resulting number is called the quotient, so that the quotient is a perfect square. So these can be the questions. Among many other questions, I'm saying like these four are like a set of questions. What should be added, subtracted, multiplied, divided, everywhere smallest. Okay. So here, to find the least number to be added or subtracted, you should use the long division method. To find the least number by which it should be multiplied or divided, you should use the prime factorization method. Prime factorization for multiplication and division. Long division for addition, subtraction. Okay. Okay, now look at this. 31. 31. Okay. So what is it? 5. 5s are 25. 6 is the remainder. 6 is the remainder. Now, what's the answer actually you got? We got an answer, right? No, 31. We said 5 is the 5. Yeah, 5 is the least number to be added. So now what you do? What is the successor of 5? See the quotient. What's the successor of 5? 6. What's its square? 36. 36 minus the given number. 5. This is the least number. Don't say there is 5 here. That's because it's 5 5s are. Don't see this 5 and this 5. Okay, so the successor of the quotient, I'll take a different number. No, that's a remainder. No, okay, nice question. That's a remainder, so you cannot go ahead. See, only if you bring a pair down, you'll have to continue the division process. Only when you bring a pair down, you'll have to continue the division process. This is the remainder. With the remainder, you cannot continue. So 5 into 2, 10, and no, because this is the remainder. You continue the division only if you bring a pair of numbers down. So 31, excuse me, 31, 5 5s are 25, 6 is the remainder. So to find the least number to be added, look at the quotient, write the successor of the quotient. See, these are instructions or steps. You need to remember and like use it while answering a question like this. What's the successor of the quotient? 6. What's the square of that? 36. 36 minus the given number, 31. 5. This is the number to be added. We'll take another example. Supposing 90. What is the least number to be added to make it a perfect square? Think before you talk. Wrong. Very good. Very good. Okay, 10. Because 9 into 9 is 81 and 10 into 10 is 100. Okay. 9 into 9 is 81. 10 into 10 is 100. What's the number here? 90. Added. So you'll have to make it bigger. You cannot come down to 81, right? What is the number to be added? So you'll have to increase the number. You cannot come down to 81. So what's the immediate perfect square after 90? Which is the immediate perfect square after 90? 100. How much you need? 10. 10 is the least number to be added.
Ma'am, I got the answer.
Okay, 10 is the least number to be added. Now, how to get that answer 10? Now, for small numbers, you can guess like this. But for very large numbers, you cannot make a guess, right? You need to have some computation procedure. you need to have a working procedure to get the answer, right? That's what we're trying to understand now with a small number like 90, because it is 10. So how to get 10? We'll see the method. So now 9 nines are 81. What's the remainder? 9. What's the quotient? 9. What's the successor of 9? 10. What's its square? 100. 100 minus the given number, 90. All right. Yeah, now what this? Oh, sorry. So find the square root, write on the question, find the square root of the given number using the long division method. The given number is not a perfect square. So when you try to find its square root, you will not get zero remainder. You will get a non-zero remainder. Yes, yes. You have to find the square root. Yeah. Let your friends finish. Yeah. See? Square the successor of the quotient. Square the successor of the quotient.
I'm 123. Ma'am.
Yeah, right. Here too, all of you got 1, 2, 3? No? You're still doing, you're saying? You're working, yeah.
Ma'am, I got correct.
123. Very good. Srijit, Anirudhan, very good.
I got the same answer.
Very good. Yeah, please complete the answer like this. Check your steps and complete it like this. The successor of the quotient is 124. Find the square of 124. You'll have to actually multiply and get it. You'll have to multiply 124 into 124 and get the correct product. And that number minus the given number, 246. That is the least number to be added.
Ma'am, I got that too.
Product is right. Very good. Please, no, don't cap it. Write down. See, that's rough work kind of. No, present it correctly. After the division, you need to write.
Finished, ma'am.
No, he's just telling his opinion, that's all.
Finished, ma'am.
Very good.
Done, ma'am.
Yeah. Finish the long division, Navneet. So if I ask you the procedure to answer this question, you must say, first, I'll find the, I'll work the long division procedure to find the square root of the given number. Remainder will not be zero because it's an imperfect square. Remainder will not be zero. Then after completing that long division procedure, I'll look at the quotient. Then I'll take the successor of the quotient. Then I'll square the successor. So I have now when you square the successor, it's a perfect square. That number is a perfect square because it's 124 into 124. That's a perfect square. So that number minus the given number, the resulting number is the number to be added. So you should remember the procedure. All right. Okay. Okay. Next one. Yeah, fast. Yeah. Okay. Next question. What is the least number to be subtracted from 77,000 to make it a perfect square? What is there to talk, Avnish? You can talk to me. Least number to be subtracted. Here, this is very simple. Whatever is the remainder should be subtracted. Okay, now look at this. What is the number to be subtracted from 70 to make it a perfect square? 6. The least number to be subtracted from 70 to make the 70 is not a perfect square. 6 is the smallest number to be subtracted from 70 to make it a perfect square. So how do you get 6 here? 7. 8 8s are 64. 6 is the remainder. Whatever is the remainder should be subtracted. Subtract to find the number to be least number to be subtracted is easy. Just do the long division. Whatever remainder you get, that number is to be subtracted. That's all. The remainder is the answer. Yeah, do it.
Ma'am,
Yeah.
that is like the 17 minus 6.
Correct.
Okay, ma'am.
Yeah, no. I was answering somebody else here. Please come again. Who is that online?
70, 8 8 are 64 and then the remainder is 6. No, ma'am. That is, we should subtract 70 minus 6 like that. Or
Yeah, correct. 6 is the number to be subtracted. Okay.
from 70.
And when you, from 70. When you subtract 70 minus 6, you get 64. That new number 64 is a perfect square.
Okay, ma'am.
Yeah. Finished. Prime factorization, long division method. Added, subtracted is long division method. Multiplied, divided is prime factorization method. Yes.
Ma'am, if ma'am, if we get the quotient, so we have to get the predecessor of the quotient, ma'am.
Here you don't look at the quotient. Whatever is the remainder should be subtracted. What's the remainder you have got?
Ma'am, I was writing.
Whatever is the remainder should be subtracted.
Okay.
What are the digits? 2. Very good.
Ma'am, I think it's 277, like.
Correct. Correct.
Ma'am, here we just do the long division, that's all.
For added, to find the number to be least number to be added, subtracted, you need to use a long division method.
Ma'am, no, ma'am, you just wrote the remainder, ma'am. In that last sum, like you did like a square and that much like that.
Yeah, those steps are to find the number to be added.
This is just like the remainder and then that's
Yeah,
all.
correct. Whatever is a remainder should be subtracted. 271 is a number to be subtracted. When you subtract 271, what is that new number you get? See, here the question is just to find the number to be subtracted, the least number to be subtracted. When you subtract, what's the new number you get? $16,000. Correct. And this is a perfect square. Yeah, what's the square root? You don't have to work. This only is a square root. The square root of this number is 277. Because see, you're getting the quotient as 277. This is the remainder. This is the remainder. So obviously, when you subtract the remainder, this will be the square root. Okay. So you have to complete your answer like this. Therefore, 271 is the least number to be subtracted from this one. Because when you subtract, this is the remainder. When you subtract the remainder, the new number is a perfect square and the square root has to be 277. When you add here in the earlier sum, when you add this addition method, 124 will be the 124. You're increasing the value, right? So then the square root of the square root of the new number will be 124. Yeah. Let me see if I have. Yeah, we'll do this one. Okay. Okay. Which is the greatest 6-digit number that is a perfect square? Which is the greatest 6-digit number that's a perfect square? Okay. So tell me the greatest 6-digit number. Sorry?
Ma'am, 999.
Yeah, how many nines?
6 nines.
Yeah, this is the greatest 6-digit number. But this one, is it a perfect square? It's not a perfect
No,
square.
ma'am.
So, yeah, so there are two conditions here. It should be the greatest 6-digit number, and also it should be a perfect square number. See, in standard 2 or 3, the question will be write the greatest 6-digit number. So you will write with your little hands for 9, you'll write 6 times, right? Yeah. Now you have another condition. It's not enough if you write the greatest 6-digit number. That should also be a perfect square. All right. So will the answer be less than this number or more than this number? Less than this
Less
number
than.
because if it's more 7-digit. Because if it is more than if the answer is more than this number, then it will be a 7-digit number. Yeah. So this is the greatest 6-digit number, but it's not a perfect square. So the greatest 6-digit perfect square number will be less than this, right? So you should use a subtraction method. You should use a subtraction procedure. We have learned two things, no, added, subtracted. You should use a subtraction procedure here. Now look at this one. Which is the least 6-digit number? That's a perfect square. So which is the smallest 6-digit number? 1 followed by how many zeros? 1 followed by how many zeros? 1, 2, 3, 4, 5 zeros. Now this is the smallest 6-digit number. All right. But it's not a perfect square because you know perfect squares will not have 5 zeros in the end. It'll have 2, 4. Yeah. If a number should be a perfect square, then it should end with even number of zeros, like 2, 4, 6, 8, and so on. But if a number ends with even number of zeros, it need not be a perfect square. Like 400 is a perfect square, but 500 is not a perfect square. 400 has 2 zeros in the end. And it's a perfect square. Its square root is 20. Like 400, 500 also has 2 zeros in the end. But that's not a perfect square. So every number that ends with even number of zeros need not be a perfect square. But you know that if a number ends with odd number of zeros, it cannot be a perfect square. Now this number ends with odd number of zeros, 5 zeros. It cannot be a perfect square. Now, okay, so you should find the smallest 6-digit number that's a perfect square. This is the smallest number, 6-digit number. Now, will the answer to this question be more than this or less than this? Because if it is less than, it becomes a 5-digit number.
Less than this.
If the answer is less than this, it will be a 5-digit number. If you subtract 1, it will become a 5-digit number. Huh? Oh, okay, okay. So here, the smallest 6-digit number is, but this is not the answer to the question. Now you have to guess, will the answer to this question be more than this number or less than this number? If it is less than this number, it will become a 5-digit number because if you subtract 1, it will become a 5-digit number. So the answer to this question should be more than this number. So the procedure is added procedure. Added. The procedure you should adopt here is the added procedure. That is, how did you work this one? What is the least number to be added? This procedure should be used there. So to find the smallest number, addition procedure. To find the greatest number, subtraction procedure. Least adding added procedure. Least add. Just remember, like least add this procedure. Greatest subtract. You can just, it's like opposite, no? So small. So you're increasing, like adding. Big. It's already big. So you're subtracting. Like something like they have some kind of opposite feelings, right? When you read these words, small. So you're adding. Like giving the opposite effect. Least number, add procedure, this procedure. Greatest number, subtraction procedure. So remember like that. Yeah. So this is greatest number, greatest. So subtraction procedure. So you first find the square root of the greatest 6-digit number using the long division method. And adding, subtracting is long division method, not prime factorization. When the procedure is add or subtract, the procedure for add subtract is long division procedure. You should start like this. You must start your answer like this. The greatest 6-digit number is should write the question. Yeah, what's the remainder? No, what? I can't see. Just just turn your book and show it to me. Correct. What's the remainder? Correct. So if you have to find the greatest number, the subtraction procedure. So whatever is the remainder should be subtracted. Wait, no, I'll tell you how to write the steps. Stop after doing the long division. I'll tell you how to continue. Completed the long division procedure. All right, I have to present the answer now. So here you should not write 1998 as a number to be subtracted. That's not the question. The question is not what is to be subtracted. You're using that procedure. You should not write 1998 as to be subtracted. You must subtract and find the answer. This number minus the remainder. This is the answer. And this is the greatest 6-digit number. That's a perfect square. Okay. So you should first write the greatest 6-digit number. That's the first step. Then do the long division procedure. All right. Greatest number. So subtraction procedure it is. So whatever is the remainder should be subtracted. Subtract the remainder from the number, the greatest 6-digit number. So you get a new number. That is the answer. That is the greatest 6-digit number, which is a perfect square. All right, next one. Done, online children?
Yes, ma'am.
All right, next one. Which is the least 6-digit number that's a perfect square?
Ma'am, I got the answer. Ma'am, I got the answer. Ma'am, I got the answer, ma'am. Hello, ma'am. Hello, ma'am. Hello, ma'am.
Anirudh, I'm helping somebody here in the physical class. Please wait.
Okay, ma'am.
Okay. Got to present the answer. Who's right? Anirudh, Sahasra.
Ma'am, yes,
Yes,
ma'am. Me,
ma'am.
I am right, ma'am.
You got 144 as a remainder.
Yes, ma'am.
Yes, ma'am.
Navneet?
I got the same. Ma'am, I have a doubt. Ma'am, no, ma'am. No.
Okay.
Finished, ma'am.
Very good. Very good. Three threes are 9. Jalak, you can just listen. 3 3s are 9. 1 is a remainder. Next pair comes down. Double the quotient. The quotient is 3. Double it. Double it. 6. Place that here. Whatever digit you place here, you must place the same digit here. So like if you put 1 here, it should be 1 here also. So now the product is 61 into 1. 61 into 1. What is 61 into 1? 61. Supposing you put a 2 here. 62 into 2 is 124. That's more than 100. So it is 61 into 1, which is 61. And the remainder is 39. The remainder is 39. Bring the next pair down. What's the quotient? 31 is the quotient. Double it. 31 into 2, 62. Now again, whatever digit you place here, you must place the same digit here. So you should keep trying like 3, 4, 5. So it is 6 in this case. 626 into 6. 626 into 6 is 3756. That is the number closest to 3900. 627 into 7 will be more than 3900. So this is the closest number to 3900. The remainder is 144. So the smallest number, the smallest 6-digit number that's a perfect square here will be, take the successor of the quotient, 317, square it. Whatever answer you get, that's the smallest 6-digit number that's a perfect square. See, here you should not write 144 is to be, you should not write this is to be added, whatever numbers to be added. Should find the answer. So 316 is the quotient. The successor of 316 is 317. Square 317 and find the answer. That is the smallest 6-digit number, which is a perfect square. Multiply, divided, we already finished. Yeah. Yeah, now back to this question. Take down this question. Okay. Now, supposing there are 30 children or say 32 children. All right, there are 32 children. You'll have to arrange 32 children in equal number of rows and columns. Is it possible to do that? No, it's not possible to do. It's not possible to, you can arrange 32 children in some fashion, in a rectangular fashion you can arrange. You cannot arrange them in the form of a square. Square meaning where the number of rows is equal to the number of columns. That arrangement is not possible with 32 students. So how many children will be left out? You will consider all the children to the extent you can make a square. Then some children will be left out, right? So how many children will be included in the square and how many are left out? Yeah. So 25 children will be included in the square and 32 minus 25. Seven of them will be left out. Because 5 rows, 5 columns, 5 into 5, 25 students. 6 rows, 6 columns, 6 into 6, 36 children. No, but we have only 32 children. 5 rows, 5 columns, 5 into 5, 25. 6 rows, 6 columns, 6 into 6, 36. You need 36 children to make 6 rows and 6 columns, but you have only 32 children. So you can maximum make 5 rows and 5 columns. But you cannot accommodate all the 32 children. 7 of them will be left out. Okay, tell me for this number. If there are 50 children and you will have to arrange them in the form of a square, how many can be accommodated in the square and how many will be left out? So 49. Correct. If there are 50 children and if these children have to be arranged in the form of a square, 49 children can be accommodated in the square and 1 child will be left out. So you can make 7 rows and 7 columns. The 50 children can be arranged in 7 rows and 7 columns. So 7 sevens are 49. 1 child will be left out. So 50 students, all the 50 students cannot be accommodated to form a square. You can make 7 rows, 7 columns, including 49 children, using or accommodating 49 students. 1 will be left out, correct? Now, if the number is 76, how many children in, how many children out? 76. And how many in? 64 in and 12 out, because 8 8s are 64. 8 8s are 64. 9 9s are 81. 9 9s are 81. So 76 is here between the square numbers 64 and 81. 8 8s are 64. 9 9s are 81. 76 lies between 64 and 81. You cannot make 9 rows and 9 columns, for which you will need 81 children. You have only 76 students, children, whatever. So you can make only 8 rows and 8 columns. So when you make 8 rows and 8 columns, you can accommodate only 64 children in that. So 76 minus 64, 12 children will be left out. They cannot be accommodated in the square. Correct? So how will you answer this question? No, long division. Okay, then. Yeah. Okay, correct. Correct. Do the long division procedure. Write on the question and perform the long division procedure. Let me just turn your book and show me your answer. I'll check. Yeah, you're right. No. Just turn your book around and show me. I want to see the remainder. No, that you have to check. I only check the remainder. 0, 0, correct. Okay. So only after performing the long division, you can answer the questions. Oh, not 171. What's the remainder? Oh, subtraction error. Okay. So the two questions. Is it possible to do so? No. That yes, no answer you can do only after performing the long division. Why do you say no? Because you're not getting zero remainder. If the remainder is zero, yes, it is possible to do so. No, the remainder is not zero. So it's not possible to arrange 74,600 soldiers in the form of a square. Only after performing the long division, you can answer these two questions. The first question is it possible to do so? No, it's not possible. How do you say that? Because the remainder is not zero. So it's not possible. If no, how many soldiers will be left out? Whatever is the remainder, 71 soldiers will be left out. Completed, online children?
Yes, ma'am.
Okay. ABCD is a square of side 15 centimeters. Find the length of the diagonal AC. Okay. Yeah. Yeah, you'll have to listen to me first. Okay. Okay, take down the question. Yeah. All right. So ABCD is a square of side 15 centimeters. See here, A, B, C, D. You need to mark it carefully. You cannot mark A, B, and C here. You should go in the clockwise or anti-clockwise direction. See, if you mark A here and B here, then C should be marked here and then D here. You must go in the clockwise or anti-clockwise directions. That's very important. A, you can see, you start anywhere. Now you can write B here or you can write B here, right? Anywhere you write A, B. The first two vertices you can mark in any direction, clockwise or anti-clockwise. So supposing you say A, B there. Okay, you should not write C here. Sorry. You should not write C here because A, B, you're going this way. So C is here and then D here. If you mark B here, A and B here, see A, B. So C here and then D here. So go in the clockwise or anti-clockwise direction while marking the vertices of any figure, any polygon. So ABCD is a square of side 15 centimeters. Find the length of the diagonal AC. Find the length of the diagonal AC. So you know every corner of a square is a right angle. Every corner of a square is a right angle, right? So this is 90 degrees. Join AC because you'll have to find the length of the diagonal AC. Now this is a right triangle. ABC is a right triangle. So in right triangle ABC by Pythagoras theorem, ABC is a right triangle. By Pythagoras theorem, the square on the hypotenuse, which is the hypotenuse AC. Why is it called the hypotenuse? Because it's opposite of the right angle. It's opposite of the right angle. The side opposite to the right angle is called the hypotenuse. So the square of the hypotenuse, AC square is equal to, which are the remaining of triangle ABC, which are the three sides? AC, BC, AB. These are the three sides, of which this is the hypotenuse. AC is the hypotenuse. Which are the remaining two sides? AB and BC. So the square on the hypotenuse, AC square, is equal to the sum of the squares of the other two sides. Which are the other two sides? AB and BC. AB and BC is equal to AB squared plus BC squared. Now say XPR, okay, is a right triangle. Which is the hypotenuse? RX. This is the hypotenuse. And these are the other two sides, right? Now square the hypotenuse. XR squared. Square the hypotenuse is equal to, take a plus sign here. Write the remaining two sides. Which are the remaining two sides? XP and
XP
PR.
square, PR square.
Yeah. You should write the square of the hypotenuse on one side is equal to the sum of the squares of the other two sides. Clear? Yeah, which are the hypotenuse? AC. So AC square is equal to, which are the remaining two sides?
AM square, MC square.
MC square. Or yeah, MC or CM, AM or MA, AM or MA, MC or CM. So it's like, you just write the three sides. AC is the hypotenuse, put an equal to sign. The remaining two sides, AM and MC, square everything. Hypotenuse square on one side. On the other side, the square of the remaining two sides, and you should add them. Simple, right? So this is the result by Pythagoras theorem. And that's what you see here. That's what you see here. So AC square as it is. What is AB? 15. AB square, 15 square. BC is 15, so 15 square. 15 square is 225. 225. The sum is 450. AC square is 450. So AC is equal to the square root of 450. If AC is equal to 450, sorry, if AC squared is equal to 450, AC will be the square root of 450. Now, how do you find the square root of 450? What should you, like, how do you proceed? Find the prime factorization of 450. 2, 225 times, 3, 15, sorry, 75 times, 3, 25 times, 5, 5s are 5, 1s are. So 450, you see the next step. AC is equal to square root of, you can write 450 as 2 into 3 square into 5 square. 2 into 3 square into 5 square. Now AC is equal to, how do you get rid of the square root symbol? From two equal factors, bring 1 out. Okay, so 3 squared, 1 3 out. 5 squared, 1 5 out. But there's only 1 2, no? So that will remain under the square root. There's only 1 2, that will remain under the square root. See, from 2 3s, 1 3 out. From 2 5s, 1 5 out. This 2 will remain under the square root because it doesn't have a pair. So 3 into 5 into root 2. 3 5s are 15. 15 root 2. So the length of the diagonal is 15 root 2. Yeah. It's not needed. You can leave the answer like this, but you can find the value of square root of 2 using the long division method. Yeah. Take down, children. Yeah. You must also show the working for the prime factorization of 450.
Ma'am, can I leave the meeting for 1 minute? I have a call.
Yeah.
Okay, ma'am.
How to find the square root of? The meaning is 15 into square root of 2. Okay, so it's just 15 root 2. 15 root 2.
Finished, ma'am.
Okay. No, I can repeat like you can. Okay, it's 15. You can write into root 2 or simply 15 root 2. Okay. Water. Completed. Harini and Jalak. Finished. Okay. Find QR and also the area of triangle PQR. Is PQR a right triangle? No, no. I hope I had a remote. You know, like so that I can control when you should start writing and stop writing.
Can you show the previous slide?
Yeah. Yeah, please do, please. Done,
Can you
Shrikjit?
go?
Completed?
Yes, ma'am.
Now, is triangle PQR a right triangle? Don't want the length of QR. Is triangle PQR a right triangle? Which angle measures 90 degrees? Q. Angle Q is equal to 90 degrees. Yeah. Which is the side opposite to angle Q?
Ma'am,
PR. So it is PR square, correct? Is equal to PR square equal to PQ square plus QR square. Plus QR square. You can also write it the other way around. PQ square plus QR square is equal to PR square. You can also write it the other way around. PQ square plus QR square is equal to PR square. Always the square of the hypotenuse should stand alone on one side, any one side. The square of the hypotenuse must stand alone on one side. Then the sum of the squares of the other two sides on the other side. Now, which side has to be found? QR, right? So you write it like this. Whatever is to be found, try to keep it on the left-hand side. See here, we are nothing, just for the sake of convenience, not that you will not get the answer or something. Here we have to find AC, right? So I wrote the result like this. Like what? AC squared is equal to AB square plus BC square. I have AC on the left hand side because I have to find AC. See, whatever you need to find, whichever side you have to find, no, try to keep that side on the left hand side. That's all it is. Okay. Whichever side you need to find, try to keep it on the left hand side. Now see here. So which is the side which you need to find here? QR, right? QR. So you write QR square plus PQ square is equal to PR square. The hypotenuse square is here. Hypotenuse square is equal to the sum of the squares of the other two sides. QR square plus PQ square. So how much is QR? We don't know. QR square plus PQ 10 square is equal to 26 square. QR square is equal to, sorry, plus 100 is equal to 676. QR square is equal to 676 minus 100. 576.
Root 576.
Square root of 576.
24.
24. Because 24 into 24 is 576. That's why memorizing the squares of the first 50 or first 100 natural numbers will be very useful. At least not first 100, first 50 will be very useful. 576, when you look at it, you know the square root is 24. Now you found QR. Next, what should you find? The area of the triangle. What's the formula to find the area of a right triangle? Half base into height or half product of legs. Area of a right triangle is equal to half product of legs. Now, this is the hypotenuse, right? The other two sides are called the legs. This is one leg, this is the other leg. You remember last year we learned like this. Leg square, leg 1 square plus leg 2 square is equal to hypotenuse square. Okay, leg square plus leg square is equal to hypotenuse square. Or you can write hypotenuse square is equal to leg 1 square or whatever. Leg 1 square plus leg 2 square. A right triangle. The side opposite of the right angle is called the hypotenuse. The remaining two sides are called the legs of the right triangle. Yeah. This is the, no, I haven't finished, please wait. This is the right angle. So the side opposite to the right angle is called the hypotenuse. The other two sides are called the legs of the right triangle. So Pythagoras theorem goes like this. Hypotenuse square is equal to leg square plus leg square. Leg 1 square plus leg 2 square, or leg square plus leg square is equal to hypotenuse square. You can write it either ways. You can write it like hypotenuse square is equal to leg square plus leg square. Or you can write leg square plus, just to remember, like is equal to hypotenuse square. You should have the square of the hypotenuse alone on one side. It should not be combined with anything else. So now you found QR, right? How do you find the area of the triangle? Half product of legs. Half product of legs, or half base into height. So which are the legs? QR and PQ. Here are the legs. The legs are QR and PQ. Half into product of the legs. Area of the triangle is 125 centimeters square.
Ma'am, I have a doubt, ma'am.
Okay, that's 24. You said, Navneet, you misled me. See again, half into base into height, half into QR into PQ. Okay, so half into QR is, I wrote 25 by mistake earlier. 24 it is. I wrote 25 earlier. Into 10. 2 ones are, 2 12s are 24. 12 into 10, 120. 120 centimeters square. Very good. Very good. Yes.
Ma'am,
Yes,
how ma'am is the product? How ma'am PQ and QR are bases and height respectively?
yeah, in a right triangle, if you regard the two legs, you can take the two legs as the base and height. Anything, if you take this leg as the base, then this is the height. Or if you take this leg as the base, then this is the height.
Okay, ma'am. I understand.
Yeah.
Finished, ma'am.
So quickly. Okay, go through the answer.
Ma'am, yes, ma'am. Both finished.
You should learn new things, right? Half product of legs. That's correct. That's correct, but I'm saying we know that already. So get used to half product of legs. Yeah.
Ma'am?
Yeah.
Ma'am, you said you will correct the assignment, ma'am, but you.
Yes. Yeah. We'll do now. Have you completed?
Yes, ma'am.
Yes, ma'am. Very nice. Yeah.
Ma'am.
Completed this, all of you?
No, ma'am.
Completed, all of you?
Yes, ma'am.
Okay. Yeah.
Ma'am, not finished.